Hello everyone, welcome to our video demonstration for our data structures and algorithm project. In this video, we'll be showing two search problems. The problem 1, linear search or lost baggage tracker, and problem 2 is binary search or online gadget store price finder. First, problem 1, we have the linear search function. Let's analyze this Python program designed to find a missing baggage tag on a series of airport conveyors. This solution is structures into three distinct functions. We have the main function, get baggage function, and the find baggage function. It will examine each one to understand its rule. The main function is the primary entry point and manages the program flows. It begins by asking for the total number of test cases to process, then iterates through each test cases. For each case, it asks first for the number of conveyors, then call the get baggage function to populate those conveyors with tag numbers. Next, it requests the specific target tag number to locate. With all the data prepared, it calls the find baggage function to perform the search. Finally, it evaluates the result. If the function returns any value other than -1, it reports the conveyors numbers, and otherwise, it reports not found. Let's proceed to get baggage function. Its sole purpose is to build the data structure for our conveyors. It loops n times once for each conveyors. Inside the loop, it prompts the user for a line of space-separated baggage tags. This line is a list comprehension. It efficiently splits the input string into individual string elements. Convert each element into an integers and store them in a new list. This list of tags is then appended to the main conveyors list. After the loop completes, this function returns a list of lists back to main. Let's proceed to find baggage function. This is we will implement the core logic. The linear search is implemented. This function receives the complete conveyors data or list of this function receives the complete conveyors data and the target tag numbers. It uses a nested loop to perform a comprehensive search. The outer loop iterates through each conveyors by its index I, and the inner loop iterates through every tag within the currently selected conveyors. During this process, this conditional check is executed. If a match is found, the function immediately stops and return I plus 1. We add 1 to convert the 0-based list index into a 1-based conveyors number of the users. If the function completes both loops without finder a match, it means the target is not in any list. Only then does it execute the final line returns -1, signaling not found to the main function. Let's run the code in linear search function. So enter number of test cases, let's say 2, and case 1, number of conveyors, let's say 3, and conveyors 1 baggage tags, let's say 101, 102, 103, and conveyor to the 202, 202, and conveyor 3 is 301, 302, 303. So, and enter missing baggage tag number. Let's say 202. So, our expected output in this case one is the conveyor. That 202 is found at conveyor 2, this line. And let's proceed to case 2. Number of conveyors. Let's say 2. And conveyor 1, baggage tags. Say 11, 12, and 13. Conveyor 2, let's say 21, 22, and 23. So enter missing baggage tag number 99. So this case is our expected output in this case 2 is not found. So the case 1 is found at conveyor 2, this line, and case 2 will be not found. Let's proceed to the second problem, the binary search or online gadget store price finder. Let's walk through this Python code which uses a binary search to quickly find a gadget price. The program is organized into three functions. The main function, the get prices function, and the find price function. First, the main function. The main function acts as the project manager. It asks for the number of test cases to run. It loops through each cases. Inside the loop, it asks for the number of gadgets. It calls get prices function to get a list of all the prices. It asks for the target price you want to find, and then it calls find price function to perform the search. Finally, it checks the result. If the function returns negative 1, the prices is not available, and otherwise it's available. Next, let's proceed to get prices function. This function is responsible for preparing our data. It reads the line of prices, splits them by spaces, and converts them to numbers. So this function sorts the price list from smallest to largest. Binary search can only work on a sorted list. It then makes sure the list is the correct length and return it main. Let's proceed to find price function. This is the core of the program, the binary search. Think of it like finding a word in a dictionary. You don't start at page 1, you open to the middle. We set 2 pointers, first at the start of the list and last at the end. The while loop, the while loop keeps running as long as first is less than or equal to last. Inside the loop, we calculate the mid position. We check the price at the middle position. If the price mid is our target, we found it. We return mid. If the middle price is greater than our target, we know our price must be in the left half. So we discard the right side by setting last equal with -1. This process of cutting the list in the half repeats makes making the process of cutting the list in half repeats making the search incredible fast. If the loop finished, meaning first and last have crossed paths, the item was never found and will return -1. Let's try to run it. So enter number of these cases. Let's say 2. So enter number of gadgets. Let's say 5. Prices. Let's say enter target price. Say 1.5. So yeah, our expected output in case 1 will be um, available because 1.5 is on the prices in this line. Let's proceed to case 2. Enter number of gadgets. Let's say 4. Prices. Enter target price. Let's say 2,000. So our expected output in case 2 will be not available because 2,000 is not found in the prices. So this is the result of the cases we test. Case 1 is available because 1.5 is on the prices and case 2 is not available. So that's all. Thank you.